This video is part one of a two-part video series for a flipped class video on the introduction to molecules and equations. Molecules and equations is one of those topics that can stress people out, so I thought I'd start off with a really peaceful and serene background. Okay, now that you're peaceful and serene, we can move on. If you don't have a copy of the assignment that we're going to be using, you can go and get it from my website, www.tinyurl.com/Rafalik Science. Look on the chemical reactions page. The assignment is titled Introduction to Molecules and Equations. So this is what the assignment looks like. It's 2 pages, and we're going to be working on the first page for this video. So we're going to start from the top and then work our way down. All right, first thing we want to do is define what is an element and what is a molecule. An element is a pure substance. And what does a pure substance mean? That means it's made of one type of atom. So, for example, we may be talking about just gold. So an example of an element would be pure gold or pure oxygen. All right, as long as it's just one type of atom, pure hydrogen. Remember, all of the types of atoms, all of the elements, can be found in the periodic table of elements. So as long as you have just one type, just germanium, just titanium, just lithium, if you had just one type of atom, then you would have an element. So that leaves us with a molecule. What is a molecule? Molecule is more than one atom bonded together. Okay, so an example of a molecule would be one thing that we're very familiar. We're all familiar with water, right? You have different atoms bonded together. And we're going to talk about this a little bit more here shortly. O2, oxygen, is bonded to another oxygen. In this case, it's both an element because it's pure oxygen and a molecule because there's more than one atom bonded together. So, water, salt, NaCl, glucose, C6H12O6. These are all examples of molecules. So let's move to this next section here. We see H2SO4. And you may have seen chemical formula like this before, but you didn't really understand what they meant. So we're going to kind of break that down to a little bit more detail. First, you have H. This stands for hydrogen. It's the symbol on the periodic table. This is sulfur, and this is oxygen. Now there's some numbers on the bottom. Let's talk about what those are. This number down here is known as a subscript. And the subscript tells you how many of this hydrogen atom there are. So this is saying that there are 2 hydrogen atoms. When there is no number, you need to pretend that that number is an invisible 1. So I sometimes will write a 1 right there. This is telling you that there's 1 sulfur atom and that there are 4 oxygen atoms in this molecule. Okay? Let's go through and answer some of these questions and see how we're doing. How many elements do we have here? Well, we have one element, Ne. We can list it. It's neon. There's one element. How many atoms are there? Well, we would look at the subscript. There's an invisible 1 right there, so we would write a 1. How many atoms are there? There's 1. Is this a molecule? Are there more than 1 atoms bonded together? No, that's not a molecule. How about number 2, N2? How many elements do we have here? Okay, well, we can still list them. There's nitrogen. There's only 1. There's 1 element here. How many atoms are there? This is where we look down here at our subscript. The subscript is a 2, so there are 2 atoms of nitrogen. Is this a molecule? Let's ask the question again. Is this more than 1 atom bonded together? Yes, we just said there's 2. So is this a molecule? Yes, it is. how many elements in this one? We're starting to get a little bit more complex here. Si. Now, how do I know if I is a separate element from the S? Well, notice that it's a lowercase I. Had it been a capital S, capital I, that would have been sulfur and iodine. But since this is capital S, small I know that it's silicon. So I have, let's count them out. I have silicon and I have chlorine. That represents 2 elements. How many atoms do we have here? Let's start from the left and work our way to the right. We don't see any subscript down here, so we know that that subscript is an invisible 1. And this has a 4. So I have 1 atom of silicon, and I have 4 atoms of chlorine, for a total of 5 atoms. And then finally, is this a molecule? Well, does it meet our definition of a molecule? Is it more than 1 atom bonded together? Well, it sure is. So yes, this is a molecule. You try answering this last one down here. Pause the video for a moment, answer it, and then check to see if you're correct. Okay, let's see what we got. How many elements are there? Whenever we're counting elements, I think the easiest way is always to list them. There's hydrogen, there's phosphorus, and there's oxygen. So how many elements are there? There are 3. Now atoms. Let's start looking at the subscript, working left to right. There's a subscript here that's a 3. There are 3 hydrogen atoms. Phosphorus, there's no subscript there, so we know the subscript is an invisible 1. And oxygen has a subscript of 4. So we can add 3 to 1 is 4, plus 4, there are 8 total atoms represented here. And is this a molecule? Once again, is it more than 1 atom bonded together? Yes. Alright, so let's draw a molecule of water using these symbols. And sometimes scientists will choose to use symbols to represent how the actual atoms bond together and what they look like. So what do we know the formula to be for water? It's H2O. So let's bring out a hydrogen and another hydrogen and an oxygen. And it just so happens the way these bond, it kind of looks like this. And we'll use lines to represent those chemical bonds. So this is how you would represent a molecule of water using these symbols. All right, how about this example? What is the chemical formula for this molecule? Well, we already showed how we would write a formula with the subscripts, so let's take a look and to see how many of each types of these elements do we have. Of the carbon, we have 1, 2, 3, 4, 5, 6. So we have 6 carbon. How many hydrogen do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 hydrogen. And finally, how many oxygen do we have? We'll do this in a different color so we don't get confused. We have 1, 2, 3, 4, 5, 6. So we have 6 oxygen. So the chemical formula would be C6H12O6, which we know to be glucose. That's what's created during photosynthesis. Now here they drew propanol in a little bit of a three-dimensional type drawing, but it doesn't change how we do this. So I'm going to pause for a moment and see if you can write down the chemical formula for propanol based on what we have here. Okay, once again, starting with the carbons, how many of those do we have? We have 3. How many hydrogens do we have? 1, 2, 3, 4, 5, 6. And how many oxygen do we have? Just 1. And we don't need to write an invisible 1 there as a subscript. It's just assumed. C3H6O. Okay, the final box on this page has to do with coefficients. So if we had CO2, and then another CO2 molecule, and then a third CO2 molecule, how would we write that? Well, I guess we could write CO2 plus CO2 plus CO2, but this could get really lengthy if we had a lot of molecules. So just like in math, all we're going to do is put a 3 in the front. And that tells us that we have 3 of these carbon dioxide molecules. So, if we were to answer the question, how many carbon atoms are there in total? Well, we could count. There's 1, 2, 3. Or we could also say we have an invisible subscript of 1, and we multiply that times the 3 in the front, which gives us 3. How many atoms of oxygen are there in total? There's 2, 4, 6. Or we could say that there's 2 times the coefficient of 3. So the coefficient times the subscript would give us 3 times 2 is 6. How many total atoms are represented here? We just said there's 3 atoms of carbon and 6 of oxygen. So 3 plus 6 would give me 9. And here's a question where people often get confused. How many total elements are there? Well, the thing I keep saying, whenever I ask you how many elements there are, you need to be able to list them. So let's list the different elements that we have. We have carbon and we have oxygen. So how many elements are there? 2. When we're dealing with atoms, we're talking about the subscripts. When we're talking about elements, I'm talking about listing them.